Hello. This video is another example of how to solve a single force problem. We've already done one of these, and if you're watching this after you've learned how to do free body diagrams and deal with multiple forces, this video is probably not going to be the most helpful thing for you. So you might want to look at one of the other examples that has more than one force. But in general, if you only have one force, the equation F equals ma is how you go. And the other problem I've done is number 3 here, where it basically asks you to solve a motion problem first, get acceleration, and plug into F equals ma. So I'm going to do one here that requires us to do the opposite. We're going to solve for F equals ma first and then plug into motion. Start every problem basically the same way. You write what you're given. So I have 1,000 newtons. I have 350 kilograms. I have 7 seconds. So just using our units, we know that newtons is force, kilograms is mass, and seconds is time. So this is enough to use F equals ma, so let's do it. So 1,000 equals 350A. We'll divide by 350. And that gets us 2.86 for acceleration. Meters per second squared. All right, so now we're probably going to have to do a motion problem because it's asking how fast it will be going and how far will it be going. So there's actually 2 problems here. For how far, that's a position, so I'm probably going to want to use the equation that relates time and position, which is that one. And for how fast, I'm going to want to use the one that relates time and velocity, so that one. So I guess we'll start by just making sure there's no unknowns that I haven't recorded. And I feel like I haven't mentioned original position. I like to do these in a different color just to remind me that they weren't given. And it doesn't say anything about how fast we were going at the beginning, so I'm going to say VO is 0 meters per second. All right, so we'll use our how far equation. I really like to copy these down. We notice students sometimes plug in wrong, and if you're plugging in right under the original equation, you don't have that problem. These are my own problems. I've been doing these for years, and I still need to show this much work to do them. So if you think you're going to be doing them in your head, that's probably not the best strategy at first. All right, so x is what we want to know for how far. XO is 0. VO is 0, so VO times t is also 0. We put in our acceleration and our time. So we're left with 0.5 times 2.86 times 7 times 7. So x is 70.07 meters. All right, so now we'll do the same for velocity. So v equals VO plus AT. V equals 0 plus 2.86 times 7. So 2.86 times 7 is 20.02. Meters per second. All right, so that's it. That's all the work you need to do for a problem like this, and just practice them. I feel like you'll be doing well. But again, a caution. This is a single force problem, and almost every other type of problem we're going to see involves multiple forces. So you really need to look at how to make a force picture or a free body diagram, and how to account for the fact that there's usually not just one force.